Hey, so it's been a while since I've recorded anything, and I wanted to go into a series where I start to dig into various projects. And I want the main emphasis to be around Rust, but also be around systems programming. One kind of conventional thing in the Rust ecosystem is the almost facetiously now said comment of rewrite it in Rust. Translating projects is a really good way to understand a language better because you learn its nuances and you learn its quirks that don't quite maybe map necessarily or do map necessarily from the source to target languages. And although I think building stuff is really good and I see tons and tons of videos of people building things, I really think it's also a lost skill or a skill that people kind of muddle along with or don't really talk about very much, which is reading code. So I thought some of these series, like I tried an attempt at SQLite once upon a time, which is quite massive and dense, and I don't fully understand every tidbit of it. And a bit of this is going to be muddling along as well, kind of showing different techniques and verbalizing different techniques that I at least use, and maybe bringing along some that I've learned over time to better understand code bases for and to you. And that actually might help you learn languages better because when you go to a project, you're not busy trying to understand the complexities of the project itself. You can better tackle that and get a mental model for the system as a whole, and then be able to come back and work on just the nuances of the language itself. So I figured we'd take about 30 minutes or so every morning or afternoon or whatever, just to kind of crack at various projects I think are interesting. This is Firecracker. AWS released this, I don't know when. Let's find out when it open sourced. The first commit. Alright. So what we're gonna first do is let's open up terminal, and I actually do already have Firecracker clone, but let's just update on the latest. I might have a couple of things, a couple of aliases I need to update, but that's fine. Yeah. Cool. I'm kind of smushy with my typing lately. Plus, I haven't finished my coffee. So, the thing that's particularly interesting about virtualization is the cost of virtualization. You get this benefit of sandboxing things, but you lose what you gain in sandboxing and maybe a bit of security, because you have to think very hard about security when you virtualize hardware. You sort of lose in, again, possibly security and possibly performance. Actually, quite literally in performance. Last night I was looking at, Brandon Gregg, who is a legend of mine. Or a hero of mine, I guess I should say, of sorts, because of all of the performance-related documentation and tooling and etc. that he's put out there. He wrote this article about Nitro, and it actually has a pretty decent discussion about real-world evolution of virtualization on AWS. And he goes all the way from earliest days, right? Or at earliest days he wants to recount to, which is fully emulated, and he goes all the way up to AWS Bare Metal. And he gives this cool chart which basically shows, there's virtualizing software, P is for para-virtualized, VH is virtualizing hardware, so I'll explain that in a second. And so you'll see that there's also this color coding, which is bare metal performance is gray, so that's AWS Bare Metal or actual Bare Metal, these two, obviously. So no matter what virtualization technology you're picking, you're getting some non-bare metal performance, right? But virtualization is kind of interesting because you might be in an environment where you just can't pick up certain tooling that you want to use. So maybe you develop for Linux on a cluster or a server or whatever, or Linux devices, but maybe you have a Mac laptop, right? And so although they're kind of similar, you're going to lose the ability to check certain things. Maybe check if, a certain tool in your target environment is POSIX compliant, maybe. Or perhaps you're verifying that you want to do a performance benchmark or something. Now, this is kind of iffy because why would you ever do profiling or benchmarking inside of a sandboxed virtualized environment? The reason is you might be willing to accept a little bit of that performance cost, just like these, right, to gain something in return. And for cloud provisioning, what they gain in return is effectively the ability to easily ration these things out. To carve up a big piece of hardware and to slice it into pieces so that each individual piece thinks it's its own operating system on the hardware. And it may not necessarily have the same performance characteristics of that, but that might be okay. So a really good case in point is you have some initial code and some new code you want to try, right? And you don't have Linux on your system, but you don't want to rent out a server, perhaps. Perhaps you're willing to accept the performance overhead of that in order to, which may be minimal, right? There's another one that claims to be quite minimal, which is multipass from Ubuntu, which is based on the bit element reference. Here it is. It's a big C++ repository, and this is another project I really want to get into and look at. This I've actually used quite successfully on Mac to do certain things like if I know that I want to compare A to B, and I want to know with a bunch of benchmarks and some profiling and maybe flame graphs or perf report or whatever, between A and B, what's the difference? Even Valgrind, right? Then I can spin up a multipass instance, go into that instance, bring in my code, download my necessary stuff, my dependencies, and then off to the races, and I start hacking at it. Whereas I've had this pain before where I've tried to get a bunch of tooling into place to do performance profiling in something like Mac, and it is, like dtrace and others are limited by the system integrity protection, which is called acronymed as SIP. So, it requires rebooting into recovery mode and, putting in cryptic commands that will turn off certain things temporarily. And, I don't think that that's really worth my time, when I want to compare very quickly and roughly what's going on. Generally, when you're doing performance stuff, you do want the back of the envelope really fast results, right? You want to try to get the 10 times ones, the orders of magnitude ones, before you start really getting into the nitpicky ones. And if you were really starting to get into the nitpicky ones, if you are deploying this stuff onto a server, for example, your stuff is already going to be virtualized. There already is a performance cost, except the performance cost is negligible compared to your development machine because those machines are quite beefy, right, to begin with. And, for those of you who don't know what virtualization is and are kind of curious, I think that's a really good discussion as well that I'll kind of take 2 minutes to talk about before we dive into this a bit and end for the day. So an operating system is effectively the embodiment of a particular abstraction. So once upon a time, you would restart your computer and load in a specific set of software, and that software would take over the hardware. It had direct access to the hardware. Eventually, what happened was, over time, this was tricky. You tried to get standards into place so that certain people could program against the standard or program against an API. And by programming against these things, it kind of improved certain cases. But the reality is that it was still too much of a moving target. So kernels sort of solve this problem by giving the illusion to running software that it is the only thing running on a system, and that's the process abstraction. Okay? So a kernel effectively manages hardware, and it is the proxy for hardware, and programs program against a kernel, instead of the hardware itself. Actually, in some cases, they will program against the hardware itself. But then the kernel will sort of emulate things, right? Virtualization is the illusion given to an operating system that it is the only operating system running on a piece of hardware. So it's like the process abstraction, except now embodied entirely for, an operating system. And there's many different types of virtualization. There's fully emulated virtualization. I'll give a link to the Brendan Gregg article at the end of at the description of this video. But there's like fully emulated, which you've probably seen projects where people will do things like they'll do things like make an NES or an SNES CPU emulator, a chip 8 simulator. There's a really fantastic book called Rust in Action, and Tim McNamara, I hope I'm not butchering his name, does a chip 8 emulator in there. And you can also kind of crawl across GitHub or any of the other kind of flavors of this GitLab, etc., to try to find projects that do SNES, NES, Game Boy. Those are really common targets that have no knowledge about the platform, as well as different ones like, you can actually take a Raspberry Pi. I think that there's like an operating systems course or whatever that does this, where they actually build out a full operating system on top of a Raspberry Pi. But fully emulated is supposed to be you're faking it, right? Valgrind actually sort of does this, where it sort of runs your code in this fake environment, this sandbox environment, and it records all the stuff that your program is doing on it as a proxy before it actually lets the program have it. And that's how Valgrind gets really, really stable numbers when you run it. So if you run cache grind across the program, you get really stable numbers every single time you run it for, say, instruction references, right, and etc. So virtualization sort of takes this idea of having all this sort of interconnected stuff, and maybe you have a fully emulated environment, but then you start saying, well, I actually don't want a fully emulated environment. I want to start, getting a little bit better performance, a little bit better control of security, etc. Well, in that case, you might dig into deeper cases with virtualization where you start either emulating in hardware, emulating with software, right? So you might do things like traps. You might trap into particular calls. And there are some actual really good histories of virtualization that are sitting around on the internet. Let me see if I can get an example of this, maybe like type 1 and type 2. There's nested virtualization. I mean, I'm kind of finding it hard to talk about it so succinctly because it is such an absolutely massive topic, right? And you can virtualize specific pieces of hardware. You can virtualize the whole kahuna. It's really quite important to understand that virtualization is a beast, but it's quite interesting as a subject because a lot of people are really interested in operating systems, and the sort of natural extension from operating systems is, okay, now you've given running code the ability to have this illusion that it has access to all memory and it has access to all of the resources, etc., even though it might have neighbors. Additionally, virtualization is the idea from a hypervisor standpoint, right, or similar, that an operating system is the only operating system on a piece of hardware or not. So that's the most succinct way I can describe virtualization. So Firecracker came out ways back. I probably could find a release date at some point where we could look at the first commit on this. But Firecracker effectively is, I believe, what Amazon uses for like Fargate and Lambda. They now, on a lot of their newer instance types, use Nitro, which is effectively their sort of virtualized in software but included like integrated chip, I think, platform, where Nitro basically gives this ability to really, really get down closer to metal performance, because it's a lot more, well, it's effectively being interstitial at that point, rather than being this sort of fully software layer thing with Zen or VMware or whatever. In this particular case, Firecracker is what's called a micro VM, and AWS is really, really particular about security, at least from what I know, reading and watching stuff in the past. Like, there's a discussion, there's videos out there about the origins of S3, which has a really big emphasis on security, and this has a really big emphasis on security as well. So let's get into it, right? We've got about 15 minutes left, so yeah. So I was muddling around with this the other day, and one thing we want to do is we want to look at what we need. So getting started is up here. I don't know why this isn't syntax highlighting anything. Yeah, so here's getting started. And it says to get started with Firecracker, download the latest release binaries or build it from source. So we're going to build it from source because that's what I'm curious about. But I think a really important thing to start off with, whenever you get handed code, you always want to get it running. That's one possible way that you can start getting into code. I've been given really large, 30,000 source lines of code plus code bases where I have not done this necessarily. I never ran any tests or the program itself up front. And that's another approach we'll talk about in the future, which is like you can kind of do the hardcore Donald Knuth, treat it like a puzzle perspective. But for these next 15 minutes, we're going to focus on the get it running thing. And I think I touched a bit on this with the SQLite videos as well. So when you have Firecracker releases and you're building it from source, one thing with Rust projects is there's this convention of using a Rust toolchain file. And if you don't know what this is, it's a really, really good idea to put onto your projects, especially if you're using nightlies. The recommendation that I'm giving you is for stability. If you pin it to a version like nightly-2020-01-01, I don't know, 1st of January 2020 or something, right? Or 2021 or whatever. When you pin nightlies, then, and you build it and you know you're building it, then when you come back to the project and you run cargo build, you're not going to run into this problem where you just run rust update and then now it's not building anymore. So all the toolchain files do, right, is basically ensure that they override the running version or the default version on Rust up. So I don't believe this project has any. Where am I? Oh, in repos. So that was Starship, which we could look at another day. It's a different project. But let's go into Firecracker and look for Rust toolchain, and there's nothing. And we can also do Rust toolchain as a file. So RG and FD, if you don't know what those are, that's root grep and find. I'll give links to those descriptions to those projects afterwards. So then this is saying, okay, you can build Firecracker on a Unix Linux system. This is Debian, I think it's Bullseye. Yes, yeah. Which is past Buster's. So Buster's 10, I think Bullseye then it is effectively 11. So they have a bash script here, which is them cloning the repository. We've already done that. We go into the directory. We've already done that. And then it's asking us to do this tools dev tool build, and then toolchain uname m unknown Linux musil. So this is a bit of a hint. If you don't know what musil is, or muscle, I don't know how you're necessarily supposed to pronounce the acronym, but it's a statically linked version of libc. That way you can build statically linked programs, so everything is just one big binary blob. That's what static linking is. Whereas dynamic linking is, you got a big portion of your program that doesn't have to be bound together. And static linking is nice because from a security standpoint, it means you're not randomly running the code on a platform where, say, libc has been compromised. So you can run it anywhere and know that you're just running your code and the code that you expect to run. And the additional thing about it is that it gives you a sense of portability. So if you want to run a one version of a Rust program that was built against, say, Ubuntu 1804 or something like that, on Debian stretch, then you might run into very subtle bugs. You may or may not, right? It just depends on the libc version and a bunch of other factors that could go wrong. And when you statically link things, you kind of remove that equation, so you could run it on either environment and be fine. But in reality, if you know that you're just running it against one, that's totally fine too, because it means that now your program is a lot more slim, and you can also, in some cases, swap out things. So the first thing we're going to do is we're going to kick this off. About to pull Docker image. So I don't know what this DevTools DevTool thing is. So first, let's see if it's a script. It is a script. It's actually a shell script, I believe. Head is DevTool. Yep, it's using bash. Here's the description. It says, let's extend this to maybe. Make sure you have Docker installed and properly configured. And it's giving some things to DevTool dest, DevTool build, DevTool shell. Okay. So that's kind of interesting. We'll look at that later. Deep dive, DevTool shell. So tools, DevTool, build. Yes, we're gonna pull that thing, and I'll open up another terminal here while that runs. And then it wants us to export this guy. Actually, why am I doing it manually when I can just copy it? Oops. There you go. Let me see, it's x86-64 and I'm Linux Mutual. This is an x86 Intel machine. So it's a i9 9900K. So this is curious because it doesn't mention about cargo build. Alright, so also another thing is, since we mentioned the muscle thing, muscle, I don't know. Let's see if we have muscle here. We do. C group mount point does not exist unknown. Okay, so let's dump that into place. The inevitable problem of copy-pasting text on between your text editor and C group mount point does not exist. I'm gonna have to get used to this computer. It's been a while since I've run stuff on this. There you go. So generally when I find issues like this, I try to go to the most recent thing. And before you just go dumping stuff into place. So Let's see what version of Docker we're running. This is 1903, so upgrade Docker. Docker does want to be updated, so maybe it's a version thing. It was Docker 1.5-2. I wonder what that's going to mean then. Docker version 1903. Well, we can try again because so this is Windows Subsystem Linux 2. So that doesn't exist. There are the C groups in here, but there's none for System D. I don't know why System D matters in this case. Okay, it's talking about something else. This guy does mention that he's on Debian, and he said that he had to do this, so I don't know. I'm guessing what this effectively is doing with C groups and containerization is something we'll talk about as well, including FreeBSD jails. Yeah, that seems to have done it. And it also looks like that's output from cargo build. So cargo build or cargo check or something. It looks like cargo, I don't know where actually. So it's fetching dependencies. That's kind of cool. Effectively, if we go find the image that it installed, what was it? This one, public ECR AWS. How do I get this to copy paste? ECR Firecracker. I'll find it from here. There we go, Docker image. Ah, right, sorry. I'm trying to access it indirectly. There you go. That's the dev tool. So let's just get rid of this and do that. Huh. I thought I had found that the other day. Cool, so it says that let's build cargo target. X86 unknown, Linux Diesel. So it built debug images, And it looks like we have two binaries, so we've got Firecracker and Jailer. So if I run Firecracker, do I get anything? Well, it is an executable. So it says there's an error. It tells us specifically where. Error created a HTTP service, permission denied. Okay. Run help. Cool. So here's Firecracker's arguments. So there's API socket, boot timer, config file, help, ID level, log path, no API, set comp level. That's a security thing. Firecracker uses setconf BPF, which we'll talk about one day. Show level, show log origin, start time CPU US, microsecond, sorry, not US. Start time microsecond, cement version. Sorry, still waking up. Cool, so we've done about 30 minutes of getting this built. I think that's a pretty good point to stop at. And then there's also this Jailer thing, which is interesting. Sorry, I can really show that I need a second copy. There's also this Jailer program. It seems that it has an exec file, group ID, an ID, a user ID. You can specify C groups, a root based, which is change root, demonizing, help, NetNS node version. So I think one of the things with learning new projects is kind of like taking a really fat, it's like taking a really fat, textbook or something. Right? I've got all these on my desk. You don't, and there's also tons behind me you can see. You don't pick those things up and immediately go, I'm going to read it from start to finish. You could. You technically could, and some people do, and I've done a bit of that in the past. But what's a way more effective way of doing it is to get the really big concepts first. So you take it and you look at the table of contents, and you find things that are interesting, right? Oh, I don't know what that is. What's this thing? What's setcomp BPF? What's BPF, right? And as you start to collect these ideas, you're collecting the really big nodes, right? Those are the big rocks that you fill the jar with. And then you're going to slowly put in the more and more kind of smaller granules of stuff into the jar. And eventually you'll fill up the jar with more and more knowledge. Now, I don't like this analogy because it gives this idea that eventually you'll fill the jar with all, you'll know everything, right? If you just keep filling the jar with finer and finer grain details. Knowledge is a bit like Zeno's paradox. As you keep filling that jar with finer and finer grains, you're going to find that the mountain that you thought we were climbing is going to eventually wind up being another mountain past that point, right? You reach Mount Everest and you get to the very top, and imagine getting to the very top and then going, crap, right? Like there's a whole other mountain past. In this particular case, since we've already built this, the additional thing that we can do next time, either this afternoon or tomorrow for me, is we can start running tests, and we can start mucking with tests, and we can start mucking with the program and seeing things that we can do. And not only do we want a good knowledge of what's in the system from a modular standpoint, but we also want a really good idea of, so it's like this does all argument parsing or service parsing, or this is the logic and the glue logic that pulls together all the core logic. That sort of knowledge is good, but then also, like what I was saying with table of contents in the jar, you want the really top level ideas of what is this thing doing. And let's give a really good example here. You'll actually see that the Firecracker source code is these 3 modules. And if we run wcrel on each of those RS files, you'll see there's 741 lines total, which is astonishing, right? We can also do a bit of trickery here, and you'll see that there's about 45,000 lines of code total, and it's not all just in Firecracker. Firecracker is storing all of its knowledge of the utility tool, the CLI tool, in those short couple of codes. Short couple of lines, right? Sorry, not a couple of lines, what was it? 741 lines, right? Almost 1,000 lines for the command line utility. But you'll see that there's other things in here like VMM, VM memory, Virtio, Gen, utils, snapshot functionality, setconf, rate limiter, etc. All of these are separate crates, right? Maybe crates, maybe other functionality. It just depends where we find cargo toml files. Yeah. These are all individual crates. And if we look at the top level crate, you'll see what members there are. So the default members is source Firecracker, so it's always going to build that. The members of this workspace are Firecracker and Jailer. And Firecracker probably has a dependency on all these other things, as well as Jailer. So if we go cat source Firecracker, you'll see that this guy relies on these local paths, so API server, logger, mmds, poly, setconf utils, and VMA. And then likewise for Jailer, you'll see all of these local ones. Not many, if any. Oh, sorry, I'm looking at the same thing. Yeah, just utils. So we'll dive into it next time. I'm going to stop there. That was pretty cool. We got, to recap, we pulled down the project, we built it, we did a little bit of fudging on Debian to fix some Docker issue in order to build it. It built images in the container, and then through a mount point, actually wrote the target binaries out on my local disk, and then that's that. So next time we'll dig in some more. Cool. See ya.